Hi class, this is lesson 8.4, transforming quadratic functions. So one of the things we're going to review today is what a parent function is. So when we were back in chapter 4, we learned that the parent function of any linear equation is y equals x. And then remember, you can do all sorts of things to that. You could add a value in front of the x, you could add a constant onto the end, and so on, okay? Now our parent function for any quadratic quadratic function is going to be f of x equals x squared. So we're going to take that x squared and then we build on that. We might add a plain x, we might add a constant, we might add something in front of the x squared, okay? But everything is going to build off of this x squared here. So one of the things we need to learn about that, here it's graphed right here, this x squared. The vertex is 0 at the point 0, 0. The axis of symmetry is x equals 0, which is the same as the y-axis. And it has only one 0 because it only touches that x-axis one time. And that's where the vertex is. Okay, now we learned back in lesson 1 that the value of a, remember a is whatever's in front of the x squared, that determines whether the parabola opens up or down. So if it's positive, it opens up. If it's negative, it opens down. It also determines the width. Oops. So the width is also determined by whatever our a value is, okay? So on these examples here, they give us a couple different ones. So here in red, we've got f of x equals x squared. And then in blue, we've got the next function where we have 1/4 in front of the x squared. And so you can see that that 1/4 made the graph get wider. So what we do to figure that out is we take a look at the absolute value of whatever our a value is. And the bigger it gets, so for example, like 2 is bigger than 1, then it's getting narrower. Whereas in this other one, on the 1/4, it got wider. Okay, so when we do examples like that, we're going to look at whatever the a value is. So on this one, a equals 3. On this one, a equals 0.5. Okay, and then we compare the absolute values of those. So 3 versus 0.5, well, 3 is going to be narrower because it's larger. Okay, so from narrowest to widest, we would say it goes f of x, and then it goes g of x. Okay, on this next one, remember on this one, our a value would be a -1, and here our a value would be 2/3. Okay, so now remember that we want to look at the absolute value when we're discussing these. So the absolute value of -1 would just be 1, and then versus 2/3. So the bigger one is 1, so that one would be the narrower one. And then the wider one would be g of x, which is our 2/3. Okay, on this one we've got an a value of 1. Here we've got an a value of 1/2. And here we've got an a value of -2. So remember, we want to consider the absolute value of that. And so we are going to think of it as 2 when we're determining how wide or narrow it is. So my biggest value now is my most narrow one. So that would be my 2. So h of x would be most narrow. My next biggest one would be 1. So that would be f of x. And then my smallest number would be my widest graph. So that would be g of x. Okay, and then on this next one, my a value is -4. Here it's 6, and here it's 0.2. Okay, so remember, we want to think of them all as the absolute value, so the positive version of themselves. So we want to think of that -4 as a +4 when we're considering widths. So now my biggest one, so that's my 6, that would be my most narrow. And then my next biggest one would be next, and then my smallest one is this 0.2, so that would be my widest graph. Okay. Alright, so now on this next part, we're going to talk about the value of c. So remember, that's our constant. It doesn't have any x's with it at all. Okay, and so if that value of c is positive, that determines our y-intercept, and so it would be translated up that many. Whereas if it's negative, our y-intercept moves down on the y-axis. So here on this one, when we're comparing it to what it started with, that x squared didn't change at all, but the 3, and it's a positive 3, so we would say that this translated up, it just slid up 3 units. Okay, compared to where it started at as just x squared. Okay, this next one, we would say it translated down 3 since it's a negative 3. And again, this is translated up or down on the y-axis. And then this last one translated down 4 since it's a negative 4. Okay. All right, so now these last examples, they might have done more than one thing to it. So when we describe what happens, we're going to have to describe everything that changed from where it started as just an x squared. So this one, the only thing that changed was this 3. So remember the a value, what's in front of the x squared, determines whether it's narrower or wider. So in this case, it got narrower because 3 is bigger than what it would have started at as a 1. So it got narrower. Okay, this next one, again, the only thing that changed was this negative 1/2 out in front compared to the 1 it used to be. So on this one, 1/2 is smaller than 1, so it got wider. And notice that that negative sign is in front of there now. And so now that parabola is going to open down instead of up. So we would say it got wider, and g of x will open down. Okay. This next one, the only thing that changed was this 3/2 out in front. Now 3/2, remember, is the same as 1.5. And so this is actually bigger than the one it started with. So this graph, we would say g of x got narrower. Okay, and it's still positive though, so the parabola didn't flip at all. Okay, so it would still open up. Okay, now these ones down here, they had a couple things happen to them. So here we had this 3 and this 9 got tacked on. So this 3 in front, it's bigger than 1, so we would say g of x got narrower. And then that 9 on there means that it translated. So we would say that, and it translated up 9, since it's a positive 9. Okay, this next one then, the things that changed was the 1/2 and the 2 from our original x squared. So 1/2, since that's smaller than 1, we would say it got wider. And then that plus 2 means that it translated up 2. Okay, and then the last one, we are going to look at this negative 1. Remember, that's an invisible 1 out in front there. And then this negative 4. So this time, since it went from 1 to negative 1, it didn't get wider or narrower or anything. The only thing that happened was that now it's going to open down. So we'll say g of x will open down as compared to up. Oops. Oh, my pen's doing crazy stuff. Let's try that again. So g of x will open down. And then that negative 4 just means it will get translated down 4. Okay, since that's a negative 4 tacked onto the end there. Okay, so remember, you're looking out for whether it got narrower or wider, if it translated up or down, and then if the way the parabola opened changed or not. And so that's whether it went from negative to positive or positive to negative. So on some of these, you might have had 3 things happen. Some of them might just have 2 things happen. Some might just have 1, but you want to look out for all 3 of them. Did the direction the parabola opens change? Did it get wider or narrower? And then did it translate up or down at all? Okay, so those are the only three things you need to be on the lookout. Otherwise, you should be good to go. Make sure as you're doing your assignment, you check your answers, and let me know if you have any questions. Good luck.